Hi everyone, this is Nafish. In today's lecture, we're going to go over radar range resolution and maximum detectable range of the radar. Okay, so these two are very important parameters whenever we're going to design any radar system, and I'm just going to show how they are interdependent. Okay, so basically, I'm doing this simulation in context of automotive radar because you can see the frequency component is in gigahertz range, 76 to 77, the sweep bandwidth. Okay, and basically we need to see how they are impacting each other, the range resolution and maximum range of the radar. From the name itself you can understand what is maximum range of the radar, okay, like how far the radar can see. And the other thing is like range resolution. This is like, you know, if there are two closely spaced object, whether the radar can separate those two objects. Okay, so basically that is called the range resolution, and that is something we get from the bandwidth. Okay, so let's run this simulation and I'm going to explain how they are kind of interdependent. So here, if you look into this range, I have two objects at 5 meters, one is at 9 meters, and if I run the simulation, I get one peak at 5 meters, one is at 9 meters, and I have taken half of the amplitude of the second object. So basically, you know, there is some path loss or whatever. You can just imagine, like, you know, I'm just getting some loss from the system. Okay, and if you look into this parameter, the bandwidth, this is 250 megahertz. Okay, and the range resolution is zero point 0.6 meters, meaning if two objects are separated by zero point 0.6 meters, the radar will be able to detect those two objects as two separate objects, or else if it is below than that, it will not be able to detect those two peaks. Okay, and one thing you can see, like, this is kind of the maximum range from this equation. This is dependent on the bandwidth as well. So this is, you know, inversely proportional to the slope s, and the slope s is directly proportional to the bandwidth. So meaning, like, if I increase the bandwidth, the maximum range is going to um, reduced. Okay, so here I'm easily you know, able to distinguish two objects because they are separated by 4 meters, right? Now let's change the um, distance to 7 meters. Okay, and then run this simulation. Okay, here you can see still I'm able to distinguish two objects. One is at 5 meters, one is at 7 meters. You can see a peak over there, and you know, still, like, you know, satisfying this thing, this condition. Okay, and we have maximum range of 24 meters. So the radar can pick up an object up to 24 meters. Okay, now I'm going to reduce it to, let's say, 5.5. Okay, and try to see whether I can resolve these two objects. Okay, and now you can see, like, there is only one peak. Okay, so meaning, like, radar is providing information about only one object, and it's kind of spread it up, but, you know, just only one peak, meaning only one object is detected. Okay, and you know, the max range is same because I'm not changing the bandwidth, but now I'm going to change the bandwidth. So let's say, keeping the distance same, but the bandwidth is, let's say, 1 gigs. Okay, and let's run this simulation. Okay, and now we can see, like, I have a bandwidth of 1000, um 1000 megs, which is 1 gigs, and I can see, like, we have two objects, so there are two peaks there. Although, like, this peak is, like, you know, it's kind of very much attenuated, but still, like, you can identify that two different objects here. Okay, and you see the range resolution right now is 0.15 meters, meaning, like, you know, this radar can separate two objects, very closely spaced object, which are 0.15 meters apart. Okay, and but you can see, like, the maximum range has been reduced. Previously it was 24, now it is 6, meaning the radar can see up to 6 meters. So if you want to get better resolution, you are going to give up some of the maximum range, or maximum detectability of the radar. Okay, and one thing is, like, you know, sometimes you can use some advanced signal processing. For example, like, let's say I want to use like 5 and 5.1. Okay, and then run this, and you see I'm not able to detect these two objects as a separate object because, you know, I'm not this range resolution is less than whatever, you know, I have provided the information right here. Okay, but you can use some advanced signal processing technique, like music, and try to see whether you can distinguish these two objects. I can try to do this simulation in one of my later videos, but I think the key thing here is try to find an optimal bandwidth and the range you want to operate on. Okay, so right now I provided 5.6 and you can see two peaks here, and this simulation is without the impact of noise. Okay, so when you have noise in the system, this will be much more difficult to separate these two objects as well. Okay, and also, like, this amplitude variation, I have just like kept half of this, each other, like half of this, but in reality this can also create some issues detecting two objects. Okay, I hope you guys learned something from this video.